This video will talk about the distance and midpoint formula. So we first talk about the distance formula for points on the real life are given two points A and B with coordinates x1 and x2. Then the distance between these points is defined by the absolute value of the difference between x1 and x2. Okay? Meaning that the distance from A to B is actually the absolute value of x2 minus x1. For points on the plane, the distance formula is a little bit more complicated, but actually it can be deduced from the distance formula for points on real life. So now given two points A with coordinate x1 or y1 and B with coordinates x2, y2, then if we want to compute the distance from A to B, then first note that the coordinates of A and B actually tell us that if we project A and B alongside the y-axis, then we get 2 points with coordinates x1 0 and x2 0. And if we project A and B alongside the x-axis, we get 2 points on the y-axis with coordinates 0 y1 and 0 y2. Okay, so these are points that lie on the axis. So using the distance formula for points on the real life, so actually we can see that the distance between these corresponding points are actually the absolute value of x2 minus x1 and absolute value of y2 minus y1, as shown in the picture. So in order to compute the distance from A to B, given these quantities, we denote by C the point with coordinate x2, y1, so that the triangles AC and B is a right triangle with ACB, the right angle. Okay, and it can be seen that the distance from A to C is actually the absolute value of x2 minus x1, and the distance from B to C is actually the absolute value of y2 minus y1. So from the Pythagorean theorem, now we know that the distance from A to B is actually the square root of the sum of square of x2 minus x1 square and y2 minus y1 square. So this is actually the distance formula between 2 points on the plane. For example, given the point A with coordinates 2 and 5, if we shift the point A 3 units to the right and 2 units down, we need to find the coordinates at the new points and try to find the distance from this new point to A. Because we shift A 3 units to the right, meaning that we will add 3 units to the coordinate, the x coordinate, and because we shift A 2 units down, meaning that we will take away 2 units from the y coordinate of A, meaning that the new point C will have coordinate 5 and 3, right? And because of that, we can easily compute the distance from C to A using the formula we have seen earlier, and it gives us actually the square root of 3 square plus minus 2 square, which is the square root of 13, right? And now another example where actually B is point with coordinate minus 1, 6. If the point B is shifted 2 units to the left and 4 units up, then the new coordinates of the coordinates of the new point is computed as follows. So because we move B 2 units to the left, meaning that we have to take away 2 units from the x coordinate of B, and because we move it 4 units up, then we have to add 4 units to the y degree, meaning that minus 3 and 10 is the coordinate of the new point C. And we can also easily deduce the distance from C to A in this case, which is the square root of 20. So the remarks we want to make here is that, well, no matter how we shift point to the left or to the right, as long as it is shifted horizontally, then only the number counts we don't really care about the sign. For example, here in this case, we will shift 2 units to the left, then here we have to consider -2 and in the previous example, when we shift 4 units to the right, for example, then the sign is plus. But because in the final formula, we take the square of all of these quantities. So for example, we shift 2 units to the left, here it becomes -2 squared. So because the square doesn't see the difference between sign, right? So actually the general form for this kind of question is the following. If you have a point A with coordinate A and B, if you shift its C unit either to the left, to the right, and D units up or down, then the distance from A to the new point is actually computed by the square root of C squared plus D squared. Okay, so this is the formula to find the distance from A to a new point that is shifted C units to horizontally and D units vertically. Okay. Now we come to the midpoint formula. As before, we will try to take first the simple case of points on the real line. So if we have 2 points A and B with coordinates x1 and x2, now we want to find a point M with coordinates C, which actually is a midpoint of AB. Then the meaning of midpoint is that the distance from A to M and the distance from M to B should be the same, right? So using the distance formula, we know that the absolute value of C minus x1, which is the distance from A to M, should be equal to the absolute value of x2 minus C, which is the distance from M to B. Well, because we know that C stay between x1 and x2, so C should be greater than x1 and less than x2. For that reason, we can actually expand the equation and get rid of the absolute sign. So we have C minus x1 equal x2 minus C, and we can easily deduce that C is x1 plus x2 over 2. Right? So this is actually the formula to find the midpoint coordinate. So now we come to the problem of finding the coordinates of midpoint of 2 points on the plane, given a point A with coordinate x1, y1, and B with coordinate x2, y2. Then how can you find the coordinate of M with of the midpoint M with coordinate that we noted by S and T? Well, this can also be seen using the formula that we already have for points on the real line. So as before, we project A and B to the x and to the y-axis. And from geometry, we know that when we project A, M, and B to the y-axis, then we get 3 points with coordinate 0, y1, 0, t, and 0, y2. And because M is the midpoint of A and B, then this point with y-coordinate t should be the midpoint of this point, meaning that t is actually half of the sum of y1 and y2, and you can easily see that s is also the midpoint of these, meaning that s is the value of s is x1 plus x2 over 2. Okay, so this is a formula for midpoint between 2 points on the plane. So now we come to a specific example of finding the length of the medians of the triangle with vertices A00, B60, and C44. Now let's take a look at the following figure. You have 3 points A, B, and C with given coordinates. Now we want to find the coordinate first. We want to find the coordinates of midpoint of AB, AC, and BC. And after that, once we have the coordinates of these points, we can easily use the distance formula to compute the length of each of the median of the triangle ABC. So we start first with the coordinate of the midpoint M of AB. So given the coordinate of A and B, we can easily compute the coordinate coordinate of M, which is 3 and 0 in this case, and the distance between C and M now is the square root of 17. Similarly, the coordinates of the midpoint and of AC is given by the formula, and we can easily compute as to be 2 and 2. So the length of the median BN is actually square root of 20. And last, the midpoint P will have coordinate 5 and 2, and the distance between A and P, from A to P, is actually the length of the median AP, and in this case this is square root of 29. Okay, so that is how we can use the midpoint formula and the distance formula to compute the length of medians of triangles given the coordinates of each of the vertex.